This section will introduce clustering algorithms, including k-means and hierarchical clustering. As a partitional clustering algorithm, k-means is simple but powerful for solving clustering problems. It partitions the given data into k clusters, where each cluster has a cluster center called centroid, and k is specified by the user. Clustering is to measure the distance between samples by calculating similarity or dissimilarity. Numerous distance functions can be utilized for different types of data and different specific applications. Euclidean distance and Manhattan distance are most commonly used functions to measure the distance. Actually, they are special cases of Minkowski distance. Here are details on how k-means works. The first step is to randomly choose k data points to be the initial centroids from the data cluster centers. The second step is to assign each data point to the closest centroid by calculating the distance between samples and the centroids, which will form new clusters. With the new clusters, it will recompute the centroid using the current cluster membership. If a convergence criterion is not met, then it goes back to second step. The stopping or convergence criterion depends on the task and data. Some examples of stopping or convergence criteria are no or minimum reassignments of data points to different clusters, no or minimum change of centroids, or minimum decrease in the sum of squared error SSE. Here is an example of the flow of k-means clustering. In each iteration, it will assign samples to new clusters and recompute centroids. K-means has its own strength and weakness. For the strength, it is easy to understand and implement. Its time complexity is not high, since both k and t are small for real applications. For the weakness, the user has to specify the k for the clustering based on experience. In addition, it is sensitive to outliers, where outliers are data points that are very far away from other data points, and they could be errors in the data recording or some special data points with very different values. The figure shows how the outlier affects clustering results. So we have to process outliers to enhance the performance. For instance, we can remove some data points in the clustering process that are much further away from the centroid than other data points. Moreover, we can try to perform random sampling to avoid clusters. Furthermore, k-means is not suitable for clustering on nonlinear data, as shown in the figure. In summary, despite weaknesses, k-means is still the most popular algorithm due to its simplicity and efficiency. It is challenging to obtain optimal clustering algorithm for all applications, since no clear evidence shows that any clustering algorithm can perform better than others in general. Comparing different clustering algorithms is a difficult task, since no one knows the correct cluster. Besides partitional clustering methods, hierarchical clustering methods can group the data into a tree structure shown in the figure. There are two types of hierarchical clustering methods. One is agglomerative, a bottom-up clustering that builds the tree from the bottom level, merges the most similar pair of clusters, and finally stops when all the data points are merged into a single cluster, that is, the root cluster. The other is divisive, a top-down clustering, which starts with all data points in one cluster, the root, then splits the root into a set of child clusters. Each child cluster is recursively divided further. Finally, it stops when only one singleton clusters of individual data points remain. That is, each cluster with only a single point. For agglomerative clustering, at the beginning, each data point forms a cluster, also called a node, and then merged nodes or clusters that have the least distance until the algorithm is converged. Eventually, all nodes belong to one cluster. It is extremely difficult to measure the performance of clustering since we do not know the correct clusters. There are some general rules to measure the clustering quality. For example, we can employ humans to check the quality manually, but this approach is costly. In summary, clustering is a key task for data analysis, and more algorithms are still coming every year. Clustering is hard to evaluate, but very useful in practice, and it is highly application dependent and to some extent subjective. Thank you.